Today, in 20 Days of Amino Acids, you get to learn all about leucine and what it means that we consider it ketogenic. Leucine, along with lysine, are the two amino acids that we consider to be purely ketogenic. What this means is that their breakdown products can be used to make things called ketone bodies. Typically, ketone bodies are associated with fatty acids and lipid breakdown. If you think about lipids, you have these long hydrocarbon chains, and in the process of beta oxidation, these get broken down. And they get broken down, you kind of chop off 2 carbon units at a time in the form of acetyl-CoA. If you think about that last piece, you've got 4 carbons and you chop it in half, you get 2 acetyl-CoAs. And if you're building up a lot of these acetyl-CoAs, what can happen is that last step can actually reverse itself, and so you get the 2 acetyl-CoAs joined together to give you acetoacetyl-CoA. Now that acetoacetyl-CoA can get transformed into acetoacetate, and acetoacetate is one of the 3 ketone bodies. The others are acetone and beta-hydroxybutyrate. Now, beta-hydroxybutyrate is the more stable one. It is the reduced form that's less likely to spontaneously decarboxylate to give you that acetone, and so that's the form that your liver will actually send to places in your body like your brain that can't get the fatty acids through their blood-brain barrier. Your liver can break down lipids and send the ketone bodies to the brain in the form of this beta-hydroxybutyrate, so your brain can keep working. This can also, though, these ketone bodies can come from some of the amino acids. And so not all of the amino acids will break down into products that can be used to form these ketone bodies. And so not all of the amino acids are ketogenic, but leucine is one of them that is. And so the breakdown products for leucine are your acetoacetate and your acetyl-CoA. And these can be used to make ketone bodies that can get sent through the bloodstream. And so say your proteins are breaking down, your liver can actually be sending those products to your body. And in this way, you can fuel other tissues, as well as in the tissues themselves that are breaking down proteins, they can then be using those ketone bodies for fuel. Because the ketone bodies in the tissues where they land, they can actually get transformed back into acetyl-CoA, and that can enter the citric acid cycle as long as there's enough oxaloacetate present in the citric acid cycle for it to enter. And so some of the amino acids that we consider glucogenic, what it means is that we could actually go and we could take out that oxaloacetate, or we could take out malate, because we can remove that from the mitochondria. And that could actually be used to power the synthesis of glucose in the liver in order for the liver to send glucose instead of sending these ketone bodies. But the ketone bodies can be sent from proteins, from lipids. The one downside is that they can actually acidify the bloodstream, and this leads to ketoacidosis in conditions like diabetes.